Have you ever tried to explain something really, really abstract, like a line of code, to a kid? It can feel like you're trying to describe a color to someone who's never seen it before. Programming is basically the language of pure logic, and figuring out how to teach that kind of thinking, well, that's one of the biggest challenges in education today. So that's the big question for this explainer, right? How do you take these complex, heavy ideas and make them not just understandable, but actually fun and intuitive for a young mind? Seriously, where do you even start? Well, it turns out there's a blueprint. We actually got our hands on this super detailed 4-hour lesson plan made for kids between 7 and 10. It's this powerhouse session that crams 3 days of learning into one. Okay, let's dive in and break down how it works. So the whole journey starts with the most graspable thing you can imagine: movement. Forget abstract variables or functions. The very first lesson is all about one thing: making a character, they call it a sprite, come alive on the screen. It's immediate, it's visual, and for a kid, it's incredibly satisfying. The lesson plan breaks animation down into this just beautifully simple formula. It's not some magic trick. It's just two things happening at once. You make the sprite move, and you make it change its costume. Like flipping between two drawings of a character walking. And that's it. Movement plus costume changes equals animation. Simple. Now, this is where it gets really clever. This slide shows how they introduce a huge programming idea. The instructor first shows them the bad way, just dragging out the same block of code over and over and over. It's clunky, it's a total pain. And then they introduce the loop as this elegant, powerful solution. See, this isn't just about saving time. It's a kid's very first taste of what's called computational thinking, finding a smarter, more efficient way to solve a repetitive problem. And they keep it so simple. The students only learn two basic kinds of loops from their control blocks. You've got the repeat loop for when you want something to happen a specific number of times, and then you have the forever loop for action that just never stops. With just those two tools, they can pretty much automate any animation they can dream up. Okay, so the character can move all by itself. Great. Now what? Well, the next critical step is to give the user control. This is the moment a passive little animation starts to feel like a real interactive experience. And I just love this analogy. It so perfectly gets the idea across. The lesson plan uses this simple metaphor. Events aren't some scary technical word. They're just remote control buttons. For a 7-year-old, that instantly clicks. You press a button and something happens. Done. The lesson just focuses on the 3 main buttons that kids already get. The green flag, that's the big start button for the whole program. Pressing a key on the keyboard, well, that's just like using a video game controller. And clicking on the character with a mouse, that's direct interaction. All of a sudden, they're not just watching anymore, they're playing. So this is a massive conceptual leap. The program isn't just a one-way street anymore, with code running from top to bottom. It's a two-way conversation. The user does something, and the code listens and then responds. That shift, that's the absolute foundation of making a game. All right, we've got animation and we've got user control. This next step, it's definitely the most abstract one, but it's also the most powerful. This is about giving the program a mind of its own, the ability to actually make decisions. So how do you teach logic? You start with real life. The lesson grounds this idea of conditionals in stuff kids already know. If you're hungry, then you eat. If your homework is done, then you can play. This connects that abstract if-then structure of code to the simple cause and effect logic that kids use every single day. It's brilliant. And from that super relatable analogy, we get a nice, clear definition. Conditionals are just if-then statements that let the program check if something is true. Is the player touching a wall? If yes, then do this. This is how you build rules, how you create challenges, and how you set goals in a game. And again, notice how they keep it concrete. The conditions aren't some weird math problem. They're tangible, visual checks. Is my character touching the red lava? Is it touching the green finish line? Is it about to fall off the edge of the screen? These simple questions are what create the entire rulebook for their game. So we have our 3 building blocks, right? Making things move, giving the user control, and teaching the code to think. Now comes the moment it all comes together. It is time to actually build the game. Just look at how cleanly these steps map onto everything we've talked about. Step 2 is all about events, using those arrow keys. Steps 3 and 4, that's pure conditionals, the if-then logic that defines what happens when you lose and what happens when you win. And of course, the movement itself uses all those animation principles. every single part of the lesson was a piece they needed to build this final working project. And this right here is the big takeaway. What these kids learned in just a few hours wasn't just how to make one little maze game. No, they learned the fundamental trio of interactive design: animation, events, and conditionals. I mean it, almost every single game you have ever played, from Pong to the latest blockbuster, is built on these three pillars. But if we zoom out for a second, the most brilliant part of this whole lesson plan isn't just what it teaches, it's how it teaches. There's a much deeper strategy going on here, something that goes way beyond just the code itself. Check this out. This table is from the instructor's notes. It's a list of common problems that students are pretty much guaranteed to run into and the solutions for them. This reveals the real genius of the method. The lesson is designed to anticipate failure. It teaches kids that hitting a wall isn't the end of the road, it's just a problem that needs to be solved. And that is the very heart of debugging and logical problem solving. So you see, the crucial point is that learning to code was almost a side effect. The real prize, what these students really walked away with, were these much deeper skills. They learned how to break a huge project down into small, manageable steps. They learned how to diagnose and fix their own problems. And they learned how to use a logical system to bring their own creative ideas to life. And that just leaves us with a final thought to chew on. We usually think of learning logic as something for math class, with abstract formulas and proofs on a whiteboard. But what if this blueprint shows us a totally different path? What if the most direct, the most engaging way to teach a child to think logically is simply to hand them the tools to build a world, let them set its rules, and then let them play inside of it?